Today we are going to understand three-phase electricity. I am Rohit and welcome to our channel. So let's begin by first understanding what exactly is electricity. Electricity is nothing but just the flow of electrons. In a copper wire, there are many copper atoms. Let's have a look at one copper atom. This is a copper atom, and in the center you can see the copper nucleus. There are many electrons revolving around the copper nucleus. But there is one electron in the outermost orbit, which we call as the free electron. It is loosely bound to the copper atom, and this electron contributes to electricity. Do you know how many free electrons are there in a 1 by 1 by 1 cubic meter of copper? There are 10 raised to 29 of these free electrons, and all these electrons contribute to electricity. We must also know that electrons are negatively charged and they are attracted towards positive charges. Let's see a copper wire with these free electrons. Here we can see a copper wire and its free electrons. If we have a bar magnet which has one north pole and one south pole, let's assume the north pole is positively charged and the south pole is negatively charged. If we keep the north pole near the wire, all the electrons, because they are negatively charged, they'll be attracted towards the positively charged north pole, and current always flows in the opposite direction to the flow of electrons. If we rotate the magnet and the north and south pole are perpendicular to the wire, the north and south pole will cancel each other out and there will be no flow of electrons, hence no current. If we rotate the magnet more and we keep the south pole near the wire, all the electrons will flow away from the south pole and current will flow towards the south pole. Let's move ahead. Whenever we talk about electricity, there are two wires involved. One wire is at higher potential than the other wire. For example, whenever you put your mobile phone charger into your AC plug, there are two terminals, these ones, and in a battery also there are two terminals. So whenever we talk about direct current or alternating current, there are always two terminals. Whenever we talk about direct current, electrons are always flowing from the negative potential to the positive potential. But when we talk about alternating current, the electrons alter their direction continuously. As I said, the AC voltage coming into your home has two terminals. One terminal is called the reference, and the second terminal's voltage keeps on increasing, goes above zero, reaches a peak, and then again comes back to zero, crosses the reference, goes negative, reaches the negative peak, and again reaches the reference voltage. This is called alternating current. And in direct current, you can see the voltage is always constant and it's higher than the reference voltage. The AC voltage you get in your homes and the DC voltage you get from batteries. If we measure the AC voltage in your home, you will get 220 volts or 120 volts depending on your country. So guys, let's quickly understand how three-phase power is generated. Then we'll see how it's consumed by a three-phase AC induction motor. So here you can see there is a copper wire. It has free electrons. And we have another copper wire. It is mechanically 120 degrees with respect to the first copper wire. Then we have another copper wire which is 120 degrees from the second copper wire. So all three copper wires are in 120 degrees with each other mechanically. Now suppose we have a magnet in the center, and as I said, the north pole is the positive side and the south pole is the negative side. As we saw before, when the north and south pole bar magnet is 90 degrees with the copper wire, there are no electrons flowing in phase 1. These are the three phases. We will see how these three phases are generated. When we rotate the center magnet, we can see north pole comes towards the wire and maximum number of electrons flow towards the north pole. This is at 90 degrees. We can see here we are at this point. If we rotate the magnet further, we can see there is no electron flow in phase 2 and there is less number of electrons flowing in phase 1. Now when we rotate the magnet even further, again we can see it's perpendicular to phase 1, so we are at 180 degrees where there is no flow of electrons at this point. We'll rotate it further to 210 degrees. Here you can see the north pole is exactly ahead of phase 2 and the maximum number of electrons are flowing towards the north pole. It is at this point. We will rotate the bar magnet even further. Now we can see there is no flow of electrons in phase 3. We are at this point. We'll rotate it even further. Now we can see maximum number of electrons are flowing away from the south pole. This is the negative peak of phase 1. We'll rotate the magnet even further. Now the positive peak of phase 3 has come this here. And finally, when we'll come to 360 degrees, we can see again there is no flow in phase 1 at this point. So if we keep on rotating the bar magnet, we can see how 3-phase power is generated. So you can see how easy it is to understand 3-phase power generation. So when we see 3-phase power, we see it like this. But there are actually 3 different phases 120 degrees apart from each other. Now let's see when we measure the 3-phase voltage what we get. If we measure the voltage from the common point to the first phase, we will get 240 volts. This is the actual voltage which we get in our homes. And if we see the voltage between the two lines, two phases, we get 415 volts. This is called voltage line to line. But why is voltage line to line 415 volts? And why is voltage phase 240 volts? We will see in the last section of this video. So stay tuned. Now that we have seen how 3-phase power is generated, let's see how an AC induction motor, a 3-phase squirrel cage motor, consumes 3-phase power without any other equipment. This is a 3-phase AC induction motor. This is the stator, which is the stationary part. It has 3-phase windings. The red one is the phase 1 winding, yellow one is phase 2 winding, and blue one is phase 3 winding. To each of these phases, we will provide one 3-phase power. For example, for the first phase, we are providing first phase. When there is a positive half of the first phase alternating current, we can see there is a north and south pole electromagnet generated in the stator. This creates a magnetic field around the rotor. Now, the second phase will provide to the yellow windings. Because the peak is now at yellow windings, we can see the north pole has shifted towards the yellow winding. The whole magnetic field has shifted. Now when we provide the third phase to the blue windings and the positive peak comes, we can see the north and south poles have shifted towards the blue windings. When there is a negative half of the first phase, we can see the south pole is on the top side and north pole is on the bottom side. Same goes for yellow and same goes for the blue winding. So now you can see how we have created a rotating magnetic field in the stator of the AC induction motor just by providing 3-phase power supply. There is no other equipment needed. You can see here. Now 3-phase power has color codes depending on the country. In India we use RYB, in US we use black, red, blue, and in Europe we use brown, black and grey. Finally, let's calculate how we get 220 volts RMS value in our home socket, and also let's see how we get 415 volts for 3-phase power supply. So to calculate that, I have made an Excel sheet and we will go through how to calculate that using the Excel sheet. I have given the link of the Excel sheet below in the description. So if you see here, I have given the peak voltage as 354. For now, let's assume the peak voltage that you are getting is 354 volts for the single phase power supply in your home. And because it's a sine wave, the sine wave goes from 0 degrees in 30 degree increment steps. It goes up to 360 degrees. Now we have divided the entire 360 degrees into 13 steps. If you think in radians, I don't know how, but if you think in radians, I have also given the radians equivalent of the degrees. Now what we will do is, at each degree, we will calculate the voltage. For example, at sine 30, we know that equals to 0.5 and we will multiply the peak value. So 0.5 multiplied by 354, we will get 177. Like that, we will put the instantaneous voltage at each degree. Now for a single phase voltage, if you add all the instantaneous voltages, you are going to get 0 volts. But that is not how we calculate the average voltage or the RMS voltage. What we have to do is we have to take the square of the voltage. So 177 squares is 31,329. Like that, we will take the squares and we will add it up. Once we add it up, we will divide it by 13 because we are taking the root mean squares. First we have done the square, now we are doing the mean by dividing it by 13. And then finally we'll take the square root. So we'll get the answer of 240 volts. If suppose you have a peak voltage of 325 volts, you can just add it over here and you will get the RMS voltage as 220 volts. That is why whenever you use a multimeter and check the voltage coming in your home, it is 220 volt. Actually, they are showing you the RMS voltage. The peak is higher than the RMS. But that is not the case for 3-phase power supply. To calculate the 3-phase RMS voltage, you have to multiply this value by 3 and you have to divide by 13, then take the square root. So you will get 382. If you are getting a peak voltage as 354, then you will get 416 volts as your RMS voltage. So that is how you calculate the RMS voltage. So if you want to use this Excel sheet, I have given the link below. Now let's do some frequently asked questions regarding 3-phase power supply. 3-phase power supply can easily start an AC induction motor, and using just one extra wire you can provide almost 3 times the power than a single phase power supply. And just by changing one wire you can reverse the direction of the AC motor. The 3 colors are depending on your country. As I showed you before, there are different colors used in different countries. Due to the cost, we are using 3-phase. As you know, 3-phase can self-start a motor. There is no requirement of 6-phase. If we use 6-phase power supply, it will double the number of protective equipments used in distribution, in transmission. For example, you will have to use 3 times the number of circuit breakers, 3 times the number of transformers. They are in use but not as much as 3-phase power supply. In 3-phase, you can see the voltage is not going to 0. Even though the single phase voltages are going to 0, the 3 voltages combined are always providing power. If you really learned a lot from this video, then please subscribe to this channel. It will really help us, and also don't forget to like.